Hey everybody, it's Mr. Troy here. This is another video in our pre-calculus series. This is Unit 1 Polynomial Functions, and we are in Lesson 3 Quadratic Zeroes. Here we go. So our overall essential question is, how do you find the factors and zeros of a quadratic function? So we need to think about what the difference is between a factor and a zero. Let's consider the function x squared minus 2x minus 8. Now the reason we care about factors is because they're what make up our quadratic function. They're the atoms of this type of math. Or they're like prime numbers if you were just doing arithmetic. So a factor is something that will multiply to make that quadratic. So for example, x minus 4 and x plus 2 are both factors, while the actual x values, like positive 4 or negative 2, are the zeros. Those are what you would plug in to get 0. So I'll only show it for this one, but if we plug in 4, we get 0. So 4 gives you 0. That's called a zero of the function. So we've seen this slide before about polynomial functions. A polynomial function is a function such as a quadratic or a cubic, etc., that involves only non-negative integer powers of x. If we want to graph these, it could be very helpful to know many things. But for example, the place where they hit the x-axis, the place where they hit the y-axis, and factors and zeros can help us find some of that information, the x-intercepts of the graph. So in order to find the x-intercepts of a polynomial, we have to be able to break down that polynomial. And most people are not able to go directly from a large polynomial down immediately to its factors. However, most pre-calculus students will know how to go from its factors to the original polynomial. So what we need to work on is figuring out how to factor this down. From the factors, we know from Algebra 1 that to find a 0, you set the factor equal to 0, and then you solve. At first, you may have learned, oh, if I see x minus 5, then my 0 is positive 5. But we really do want to go through the steps of setting equal to 0 and then solving using those Algebra 1 techniques. That's going to get us out of a bind if we try and learn a shortcut that doesn't necessarily hold true for all things all the time. So there are a lot of different terms to juggle here, and we want to make sure that you're fluent with them. That watch your notation seems like I'm shouting at you. Give me just a second. There we go. I want you to watch your notation, but I'm not angry or anything. All right, so here are some different ways that we can say the same thing. Saying x minus 7 is a factor is the same thing as saying that 7, 0 is an x-intercept. Now that's the same thing as saying that x equals 7 is a 0, because if you plug in an x value of 7, you get a y value of 0. Other terms that we use for that are a solution and a root. So those three words, zero, solution, and root, are used pretty interchangeably, but all 5 of these statements are equivalent. So if we look back at our previous answer, our original equation is written in standard form. Then next we have a factored equation, which is called intercept form. And then finally, when we solve, we're listing our solutions, or our roots, or our zeros. So hopefully you recall from Algebra 1 that a quadratic equation is a polynomial with a highest degree of 2. recall that the equation has to have some sort of x squared in it, but it may have a certain number of x's or a certain number of constant terms, but those could be 0. So something like x squared plus 3x plus 2 counts, but so does x squared minus 1. When it comes to finding zeros of a quadratic function, we're going to think about it in 4 ways. There are a couple other ways that you'll have learned in Algebra 1 and Algebra 2, but we're just going to focus on 2 from Algebra 1 and Algebra 2. So we might factor. That's the sort of thing that you will do if you can look at an equation or look at an expression and know what multiplies. It's that process you learned in Algebra 1 of what multiplies to this and adds to that. Reverse foiling, some people call it. You may have used a method for it or something like that. The next is a method that will always work, which is the quadratic formula. Stick around after the video and I'll sing you the song, okay? Now, the 2 new ways would be to use synthetic division or long division. But here's the thing. If you're going to use synthetic division or if you're going to use long division, you need something to divide by. And when you do that division, you need to make sure that you have no remainder. Now, why no remainder? Well, something's not divisible if it has a remainder. Let's move forward. Now, here are your possible outcomes for a quadratic function. You could have 2 real zeros, or you could have 1 real zero that is a repeated solution. And this is the sort of thing that would happen if, for example, your quadratic factored to something like x plus 1 times x plus 1. Those 2 factors are repeated, so they would only show up as -1, 1 x-intercept. You could also have 2 imaginary zeros, where your 2 solutions are imaginary numbers. This would be the sort of thing where in the quadratic formula, you would be, say, for example, taking the square root of a negative number. That's how you would know that you have imaginary solutions. Your main decision when you look at a quadratic equation is, do I want to factor or do I want to use the quadratic formula? If you are comfortable using completing the square, you may want to do that. Or if you see something that sticks out to you as being an example of the square root method, you may want to use that. But your general question to ask yourself is, do I want to factor or do I want to use the quadratic formula? Now, factoring is usually easier if you can figure it out, whereas the quadratic formula sometimes takes some work, but will always result in an answer that you can work to straightforwardly. If you're choosing to factor, you're trying to figure out, is there a way that I could write that polynomial as 2 binomials? Can I think of a 3x plus something times an x minus something? That sort of idea. We're going to take 3x times x because that's the only way to make 3x squared. When it comes to making -12, there are lots of options. And the more options there are, the more likely I am to maybe use the quadratic formula. So I've listed the different ways that I could multiply to make -12. And remember, what you would be doing is putting one of those numbers here, so for example, a -2 here, and the other number here, for example, a +6. Then you're checking to see if that foils out, at least that's the term I use, to make the correct number of x's. I can see this one doesn't work because I get a -6x and a +6x. Now, there are other reasons why that doesn't work. If you're looking at it, you're saying, well, there's a greatest common factor. Of course, there's more to it. So let's try. Let's try putting a +4 4 here and a minus 3 here. This is a guess and check process until you get you build up an intuition for it. So I can see that I have negative 9x there and positive 4x. That would make negative 5x, but I want positive 5x. So what I can do is I can just switch the signs here. I want to make switch the signs there. So that will give me a positive 9x and minus 4x, and that makes 5x. From here, I just split out my factors. So I say, how do I make 3x minus 4 equal to 0? Well, if x equals 4/3, how do I make x plus 3 equal to 0? Well, if x equals negative 3. That was relatively easy, because there's only one way to split up 3x squared. This next one is going to be harder to factor because there are two different ways to make 6. You could do 6x and x, or you could do 3x and 2x. When you get to that point, that might be a sign that you want to use the quadratic formula. So let's do that now. Okay, so I did my x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And this is what I got. And I'm going to simplify. Most teachers will tell you to start simplifying from the inside. So for example, the radicand there, or the stuff underneath the square root, ends up being 49. If you end up getting a square root of a perfect square, that actually is a sign that you could have factored. But it's okay to go whichever way works best for you. Factoring is a great skill that is important in all levels of math, so you do want to do it when you can. So we're going to get negative 1 plus or minus 7 all over 12, which is going to give me either 6/12 or 1/2, or it would give us negative 8/12, which is negative 2/3. Now here's what that tells me. It tells me that had I factored, it would have factored with this set of factors, the 3x and the 2x, not the 6x and the 1x. And I know that because I'm seeing the 3 and the 2 in the denominator. So this would be 2x minus 1 and 3x plus 2. I can just kind of reverse engineer that from those factors. From those solutions. Now, problem 3 here is a great example of when you might use the square root method. So if you remember that, if you can isolate the x squared on one side and just a number on the other side, a constant term, that's when you can take the square root. So we would get x equals plus or minus the square root of 40, or we would normally write that as plus or minus 2 root 10, if you remember simplifying your radicals. For something like problem number 4, when we see a 1x squared and we have a small number of terms, let's try to factor that, because factoring is going to be an important skill that we're going to want to keep with us. So set everything to one side, subtract 4x from both sides. And I'm asking the question, what multiplies to positive 4 but adds to negative 4? Well, that would be x minus 2 times x minus 2. And when we have a repeated factor like this, when we have that multiplicity of 2, we're going to write it as x minus 2 quantity squared. So our only solution for this, we have one solution, that x equals positive 2. And of course, if you want to test any solution like that, you just plug it in. 2 squared is 4, plus 4 equals 4 times 2, which is 8. Okay, if I look at problem number 5, and I try to factor that. So I would say, well, I just had a 2 and a 2 that worked, so maybe I should try a, let's see, a minus 4 and a plus 1. Those multiply to, oh, those don't multiply to positive 4, those multiply to negative 4. Okay, so if I change this to a, let's say I change this to a negative 1, then I've got multiplying to positive 4. Oh, but what do they add to? They add to negative 5. Okay, so that tells me that maybe this doesn't factor. So when I get to that point where I'm saying to myself, maybe this doesn't factor, my next step is to pull out the quadratic formula. So I'm going to plug that into the quadratic formula. And as I'm plugging that in, I may notice that it's going to give me an imaginary set of solutions, because my b squared is negative 3 times negative 3, or 9, and my 4 times a times c is 16. So I have 3 plus or minus the square root of 9 minus 16. That's negative 7 all over 2. So we would say 3 halves plus root 7 over 2i, and 3 halves minus root 7 over 2i. One tip or trick that might be useful to you is on this final problem, if you don't want to deal with these coefficients when you go and plug this into the quadratic formula, or even as you're trying to factor, you can multiply both sides through to cancel out your denominators. So for example, if you multiplied everything here by 6, you would get x squared minus 4x plus 6 equals 0. And then that's much easier to try and figure out, how to factor or how to plug into the quadratic formula. Let's use the quadratic formula for that. So 4 plus or minus the square root of 16 minus 4 times 1 times 6 all over 2 times 1. So I've got that 16 minus 24. 4 plus or minus the square root of negative 8 all over 2, which, if you remember from geometry, the square root of 8 is 2 root 2. So 4 over 2 plus or minus 2 root 2 over 2i. Well, that simplifies down. So 2 plus or minus root 2i, which, depending on who you talk to, you can either write it as a 2 plus or minus, or you might want to write it as 2 separate answers. That's all I've got for you on this one. Thanks for watching. I hope it was helpful. Have a good one.